So day 3 is all about learning properties of limits. So we're going to go through a couple. I'm going to do the first example, and then I want you to try the second one on your own, and then we'll go over it in class. So limit of a constant basically is if you don't have any variables, your limit is just what that constant term is. So the limit as x goes to 4 of 7 is just 7. So anytime you have a constant, your limit is just that constant. So then you can try number 2. The next one is for when you have just one single variable. So the limit as x approaches 7 of x is whatever your limit approaches. So here, as x approaches 7 of x, that means my limit's going to be equal to 7. So whatever number that limit approaches is what your answer is. So again, try the next one. Limit of a sum. So what you can do is for limit of a sum, we're going to break this up and use those two previous properties to figure out our answer. So for a sum, it's like we're taking the limit as x approaches negative 4 of x plus the limit as x approaches negative 4 of y, and we're going to figure those out individually. So the limit as x approaches 4 of negative x, so remember when you have just an x, it's whatever it's approaching. So here, this limit would be 4. Limit of a constant is just whatever that constant term is, so over here it would be 9, and then I would add them together, so I would get 5. Therefore, my limit as x approaches negative 4 of x plus 9 equals 5. So you can do that same thing with the next one. Limit of a difference is kind of the same thing as the sum, except now we're going to subtract. So again, I'm going to break this up into two separate limits. So the first one's 12 minus now the limit as x approaches 5 of x. So limit of 12 would just be 12 because that's a constant term. Limit as x is whatever x is approaching, which would be 5. Therefore, 12 minus 5 is 7. So we say the limit as x approaches 5 of 12 minus x is just equal to 7. So again, try the next one. Product is the same way except for adding or subtracting. Now we're going to be multiplying. So again, we can break this up into the limit as x approaches 5 of negative 6 now times the limit as x approaches 5 of x. So the first one is another constant, so that's just negative 6. The second one is a variable, so it's whatever x is approaching. Here it's 5. So negative 6 times 5 would give me negative 30. Therefore, the limit as x approaches 5 of negative 6x equals negative 30. For a polynomial, all you have to do is plug in your x value. So as x approaches 3, that's going to be my value that I'm going to plug in for x. So this would be 4 times 3 cubed plus 2 times 3 squared minus 6 times 3 plus 5. So then you can plug that into your calculator and see what your output is. And it would be 113. Therefore, the limit as x approaches 3 of 4x cubed plus 2x squared minus 6x plus 5 equals 113. And again, try the next one. On the next page is the power one. So limit of a power is kind of like limit of a polynomial. So what we're going to do is we're going to plug in our x value and then simplify and see what we get. So as the limit approaches 5 is my x value, so I'm going to plug in 5 for any x I see and then simplify. So I got to do what's in parentheses first. So this would be 10 minus 7 cubed. 10 minus 7 would give me 3. 3 cubed is then 27. So this would be the limit as x approaches 5 of 2x minus 7 cubed equals 27. Again, try the next one. Root is the same way. We plug in an x value, we see what our output is. So here it says -2, so I'm going to plug in -2 for any x value I see and simplify. So -2 squared would give me 4. 4 times 4 is 16. 16 plus 5 is just 21. And I really can't break that down, so I'm going to leave that radical 21. So the limit as x approaches -2 of radical 4x squared plus 5 is radical 21. And again, try the next one. The last one is a little bit different. So limit of a quotient has a couple different ways to do it. So the first way is you can plug in your x value, and if the denominator is not 0, that means you can continue to do it. So the first two cases are when the denominator is not equal to 0, meaning when I plug in 1 for every x value, on the bottom I will not get a 0. So when I simplify this, I would get 1. -3 times 1 squared is just -3 plus 7. On the bottom it would be 2 minus 5. And then I would simplify that, and that would be 5 over -3. So notice how -3 is on the bottom and it's not 0. That's why this one works, where you can just plug in your x value. So as x approaches 1 of this function, my limit is 5 over -3. Or you could just say -5/3. 2 is the same way, but I want to go over two cases with you with what happens when the denominator is 0. Meaning as x approaches 3 here, so if I plug in 3, I would get 3 minus 3 on the bottom, and I would get 0, which means that would not work. So I have to figure out, well, how else can I find this limit without looking at a graph? So what you do is, when possible, we factor. Meaning, looking at the top, we're going to break that apart. So x squared minus x minus 6, I'm going to figure out two numbers that multiply to -6 but add up to -1. And that would be x minus 3 and x plus 2. My denominator stays the same. So now I notice that x minus 3 is on the top and the bottom, so it cancels out. So I'm just left with x plus 2. So at this point, you're going to plug in your x value. So my x value is 3. So I plug in 3, so I would get 3 plus 2, which would give me 5. So the limit as x approaches 3 of x squared minus x minus 6 over x minus 3 is 5. So that's one way. So like I said, if you plug in your x value, you get a 0 on the denominator. Look to factor first. So if you factor, then something's going to cancel out, and then you can plug in your x value and simplify. Now, the other case is, well, what if nothing factors? And usually there's a radical there. So what we're going to do is we're going to recall how to rationalize. This time, though, we're going to rationalize the top and bottom. So it's kind of taking that radical and putting it back in the bottom. So to rationalize, remember we use dots. So what we're going to do is we're just going to change this sign, which is after the radical. So we're going to times the top by radical 4 plus x plus 2. And we're going to multiply the bottom by radical 4 plus x plus 2. So on top, when I do that, it would be radical 4 plus x minus 2 times radical 4 plus x plus 2. So there's my dots. On the bottom, it's going to be x times radical 4 plus x plus 2. So I'm just going to focus on simplifying the top first. So when you can FOIL this out, or you can remember dots. So remember, dots is when I take the first term and square it, subtracted from the second term and squared. Or you can FOIL it out and then your middle term will cancel. But I'm going to use dots here. So that means I'm going to do radical 4 plus x squared minus 2 squared. And then my denominator I'm going to keep how it is. So radical 4 plus x squared just means that my square root and my exponent of 2 are going to cancel out. So I'm left with 4 plus x. 2 squared is just 4. So then I'm left with 4 plus x minus 4 on top, and then this on the bottom. On top, I notice I can simplify. 4 minus 4 is just 0, so I have x over x times 4 plus x plus 2. Now, if you notice, this is why I didn't expand the bottom, because the x's cancel now. So just like your 4's, your x's cancel. So I'm left with 1 over radical 4 plus x plus 2. So at this point, I needed to get this x to go away, because if I plugged in 0 there, my denominator would still be 0, which would make it undefined. So that's why I needed to cancel it, and that's why I didn't distribute. But now that I'm at this point, I can plug in my x value, so I get 1 over radical 4 plus 0 plus 2. So I get 1 over radical 4 plus 2. Radical 4 is just 2. 2 plus 2 would give me 4. So my official answer would be the limit as x approaches 0 of radical 4 plus x minus 2 over x equals 1/4. So those are the only two ways I would test you on. It would be either you have to factor and then plug in your x value in, or you would have to rationalize and then simplify and then plug in your x value. So just strategies to try if denominator is 0. That would be factor and rationalize. So now if you didn't try those ones I left blank, I want you to go back and try them. If you did, we're going to check them, and then you can move on to the homework page.